It is a three-dimensional shape. Are we solids? Yeah, we are. Are these all solids right here? These are all solids, aren't they?
Yep.
Three-dimensional shape. Not flat like flat land, but three-dimensional. Okay. A polyhedron is a solid that is formed by polygons. Okay. A solid that is formed by polygons. Okay, so you know what? It's better if you just pay attention. You really do have enough time.
He is.
Okay. So let's talk about polygons. So I have a question. Would this be, according to that definition, would this be a polyhedron?
Nope.
Let's pretend there's a side here. Would this be a polyhedron? It's a solid formed by polygons. Yeah, it is. It's a polyhedron. It's a solid formed by polygons. Okay. Is this a polyhedron? Pretending there's a bottom here. Is this a polyhedron?
Yep.
A solid formed by polygons. Does this meet the definition?
No. No one else is answering. I said yes.
Come on now. I know you guys can do this. Is this all formed? Here's a square, a square, a square, a triangle, and a triangle. Is it a solid formed by polygons?
Yep.
Yes.
Okay.
So it is a polyhedron. It is a polyhedron. How about this? Is this a solid formed by polygons? Yes. It's called a what? A polyhedron. Polyhedron. All right. Is this a polyhedron?
No. Why not?
Why not? Is it a solid formed by polygons? Is a circle a polygon?
Yep. No.
Polygon is formed by straight segments. This is not a polygon, so this is not a polyhedron. It's called a cylinder. Okay.
13.
Would this be considered a polyhedron? No, it's not formed by polygons. This is not a polyhedron. This is not a polyhedron. Okay? All right, there's more. You ready? The plane surfaces, that's the flat surfaces, are called faces, and the segments joining the vertices, I know there's a lot of words in here, we're going to go over it, are called, I know, edges. So I want you to draw a rectangle here, and then up to the side, the same size rectangle. Come on. And what do we do to make it a polyhedron? We connect the vertices. And I know, we do a little bit of thing here. Okay? So let's label this. Let's label it real quick. I'll find my other color. Here. Okay, so what is this called right here? What's that called? A face. What is that right there called? A vertex. If it's plural, what's it called?
Vertices.
Vertices, if it's plural. Vertices. And what is this called right here? An edge, thank you. Edge. Okay? Alrighty. So those are just some words we got to work with. Let's do this real quick. We're going to do it together. So state the number of the sides of each polygon. What if we have an octagon? How many sides? This is flat. This is a flat thing. 8. How about a pentagon?
5.
How about a quadrilateral?
4.
How about a heptagon?
7.
A hexagon?
6. 9.
Thank you, Vinny.
Welcome.
Okay. Now, we have to talk about, I feel like we kind of jumped into what a base is a little too quickly here. So I'm like, okay, I know what a base is, but how can I explain it the best way? So I got the book out, and I'm like, okay, let's look at the definition of a base here. Let me find it real quick. And you can tell me on these shapes what a base is. If we look at this definition of a prism, it's a polyhedron with two congruent faces called bases that lie in parallel planes. Okay, so this one right here, take a look. Hey, Vinny. So do I have two congruent faces that are parallel in this shape?
Yep.
What shape are they? Triangle. These two things right here are congruent shapes and they're parallel to each other. They are the bases, even though it may be sitting like this. Yeah? Doesn't matter if it's sitting on that part. These are the bases because they're two congruent parallel sides. Only two. Let's do another one. What's the bases here?
The green part.
I know you don't have your phone out because I'll take it away if I see phones. Okay, the bases are the hexagons, two congruent parallel sides, only two. But you say, yeah, but these two are congruent and parallel. These two are, yeah, but there's only two of these. That's the difference. Even if it's not, like here, it's sitting on its base, it may not. It may be sitting like that. And these are still the bases. This is important coming up later. You gotta make sure you can identify bases. What if I have a cube? Wait a minute. What's the base of a cube? Doesn't matter. Doesn't matter. Okay, they're all the same size. And actually, the base of this doesn't matter. Here's a pair of congruent sides. Here's a pair of congruent sides opposite each other. And it doesn't matter what the base is on these. But the other ones there are. So let's take that and do this. Tell whether the solid is a polyhedron. If so, identify the shape of the bases, then name the solid. Is this a polyhedron? Yes. What is the shape of its base? A rectangle. It doesn't matter what you choose here. I'll just say it's sitting on its base, which is a rectangle. Are the bases. And then how would we name this shape? If the base is a rectangle, it is a rectangular prism. What I want you to notice here is that we named the base a rectangle, and that's also part of the naming of the shape. Whatever the base is part of the name. Okay, is this a polyhedron? Does it meet the definition? Yes, it does. All its faces are polygons. What's the name of its base? 1, 2, 3, 4, 5, 6. Hexagon. How would I name that? Close. Hexagonal or hexagonal. Hexagonal. However you want to say it. Hexagonal. Hexagonal. Prism. So basically I want you to realize that you're naming it by its base, basically. Okay? All right, turn it over. Okay, take a look at this picture right here. Name the solid. What is this called? It's a rectangular, because the base is a rectangle. Rectangular prism. Some of you can see this very quickly. Others of us, it's a little bit kind of strange for us to conceptualize. So be patient with your friends if they don't get it right away. Okay? All right. Count the number of faces and edges. All right. Here is the same shape right here. Same shape. Okay, how many faces does this have? 1, 2, 3, 4, 5, 6. 6 faces. Okay, 6. Now, let's count the edges. See, 1, 2, 3, 4. 4 here, and 4 here. So we have how many? 12. Okay, this guy right here is a famous mathematician. I've heard his name pronounced Euler, like the word oil, or Euler. Either way, he's a very famous mathematician, especially in geometry. And he figured out this little formula. He said that F plus V equals E plus 2. What do you think the F stands for?
Faces.
Yeah, faces. What do you think the V stands for? Vertices. And what do you think the E stands for? Okay, let's plug it in and see if he was right. How many faces did we decide this has? 6. How many vertices does it have? Corners, vertices. 1, 2, 3, 4, 5, 6, 7, 8. And how many edges did we say? Oh, look how smart he was. It's true.
Oh shoot, what's going on? No.
Right in front of me.
Yeah, what are you? I got myself back.
Okay.
You don't catch me.
All right. Yeah.
I'm like, I do
It's so annoying. Okay. So that is Euler. All right, so next step here says list any congruent faces and congruent edges. Now there are a ton. I don't really want to name them all. I'm going to show you a couple. I'm going to say, okay, A, B, C, D. This up here is congruent to the bottom one, isn't it? So I'm going to say A, B, C, D is congruent to E, F, G, H. That's a pair of faces. That's a pair of faces right here. I'm not going to list the rest of them because it's too many. But let's list one pair of congruent edges. This right here and this right here are congruent. So AE is congruent to DH. Look how many there are. Ready? I'm not going to ask you to write them all. But look at how many there are. Yeah, no, we're not going to write all those.
Why would you do that?
I'm not.
Something to do that's fine.
All right. Part of this, no, I didn't write that. Part of this is sketching, being able to sketch these drawings. So we got to draw a rectangular pyramid. So what I usually do is I draw a rectangle that's kind of sideways, like I'm looking at it, you know, from the front. And then I put a little dot up on top, and I connect it. And it sort of turns out to be a pyramid.
That's cool.
So I drew this sort of crooked rectangle down here, put a dot up on top, and then connected it to all the vertices. Okay, practice. Okay, now a triangular prism. Now here's what I do. I draw a triangle. I'm gonna pretend they're congruent, even though they're not really. And then I'm going to try and draw that exact same triangle directly above it. It's not quite the same, but it's pretty close.
Like right above it?
Yep. Well, a little space in between. A little space in between. And then I just connect the vertices. And you sort of have a triangular prism.
Spear.
Okay? All right. Types of solids. We've got to be good at naming these. So, what's the first one?
Rectangle.
Yeah, because you have it written down there.
No. And the next one's triangular.
Rectangular prism. Okay.
Wrinkles.
Because the base is a rectangle. What is the base of this one? So it's going to be called a triangular prism.
I always got the next one. Spear.
It's a sphere right there. No, it's not a sphere. Listen, it looks like it's all equal sides that are all squares. We don't say square prism. We say what? Cube. Square prism. I know you do. Let's try somebody else maybe. Somebody want to name this one?
Allison.
It is a pyramid. We're going to call it a rectangular pyramid because we really can't tell for sure if it's a square. Hey, can you see the difference between these two? Prism, pyramid. Yes?
Yes, of course we can.
Think Egypt. All right.
Egypt.
This is also a pyramid, Slava. What would you call this one, Slava?
Triangular pyramid.
Right on.
I got the next one. Come on.
I bet you do. I'm gonna ask Evan. What do you think this one would be called? Very good. Pentagonal what? Pyramid. 1, 2, 3, 4, 5. The base is a pentagon, so I'm going to call it a pentagonal pyramid. Okay? Is this a polyhedron? No, because not all the faces are polygons. It's called a what? Cylinder. What's this one called?
Cone. Sphere.
And a sphere.
Planet Earth.
Okay, since I've only planned the next 3 days, I did not print a calendar for you. So I'm going to write the homework right here. Are you ready?
Yeah, no homework.
Page 476.
I'll give you money.
Shh. It looks like a lot, but at least half of it is true or false or matching. So, ready? 1 through 12.
Oh my God.
14 and 15, and you don't need to list the congruent faces here. You don't need to list the congruent faces. We also have 17 through 30 and 47 through 55 odd. Everybody got done that tried. And I managed to find 3 more books, so we have 3 more in the
I lost
classroom.
mine.
Where were they?